Welcome! On this channel, we share the freshest insights from the world of neural networks, hardware, and technology. Subscribe right now so you don't miss a thing. And if you need your own AI agent, reach out and I'll help you build one tailored to your needs. Today, our tale begins with a fascinating new model released by the corporation Vibo. It is called VibeSyncer 3 billion. Here is the map for our journey today in this explainer. First, the Agile Giant Slayer, then forging the neural network, building the local outpost, triumphs and pure logic, trials and broken code, and finally, the sovereign AI future. Section 1. The Agile Giant Slayer, challenging the cloud giants. Our hero today is VibeSyncer 3 billion. Now, you might be wondering what makes it so special? Well, this model contains only 3 billion hidden parameters, yet it confidently challenges enormous cloud giants. It actually stands up to mighty models like Claude Opus, Gemini, and GLM. Based on the Kunstdecoder neural network, it is just like the agile warrior Alyosha Popovich, effortlessly dodging a blow from a colossal stone giant. This small algorithm fights on completely equal terms with the absolute biggest names in the industry. In this epic battle, we have VibeSyncer with just 3 billion hidden parameters facing off against the Kim-K model, which boasts a monstrous 1 trillion parameters. The contrast is absolutely stark. Our nimble 3 billion parameter model actually outperforms that 1 trillion parameter behemoth. It is a true testament to the incredible power of highly optimized, focused training over sheer bloated size. Section 2. Forging the neural network, crafting the algorithm. Let us take a closer look at how this incredible power was actually forged. The crafting process follows exact chronological steps. The authors did not just throw data at a wall to see what stuck. First comes rigorous supervised fine-tuning. This really lays the essential groundwork. Then, the creators apply complex reinforcement learning to sharpen its decision-making. After that comes the special MGP0 method. Then, the model undergoes offline distillation of its very own thoughts. And finally comes the strict fine-tuning of instructions. This enormous, painstaking effort yields absolutely phenomenal results. This technique is just like the wise, ethereal goddess Moge. It focuses training purely on tasks of medium difficulty, ensuring no valuable computational resources are wasted on simple, everyday problems. By filtering the knowledge this way, it smoothly weaves shining streams of light, separating the pure sparks of insight from murky dust. The very best reasoning is then fed back into the weights using offline distillation. It is a brilliantly efficient way to learn, showing us exactly how smarter training beats massive scale. Section 3. Building the local outpost, the hardware reality. We will now shift from the software realm over to the physical home server. 45 gigabytes of VRAM total cache is required. Now, you might be scratching your head wondering why a tiny 3 billion parameter model needs so much memory. Well, the secret lies entirely in the context window. We set a massive window of 32,000 tokens. When you want the model to remember and process that much information all at once, the total cache literally explodes in size. Guarding this local outpost is our faithful fluffy spirit, the Domovoy. The environment runs on Ubuntu, utilizing SJLang and a rugged NVIDIA RTX 48 gigabyte card. While the model weights themselves take up only 5 gigabytes, we absolutely needed that beefy NVIDIA RTX card to hold all the VRAM cache for our massive token window. This is an incredibly powerful local setup, proving that you can run cutting-edge magic right in your own home. Section 4. Triumphs in pure logic, the trial of mathematics. It is time to put our agile hero to the ultimate test. We subjected it to the Voyager flight path test. This rigorous benchmark requires calculating the Voyager station flight path using complex formulas and pure mathematical logic. Like the winged cyber dog Simargl carving a glittering route between the stars, the model flew swiftly through these formulas. It thought deeply, avoiding any dangerous hallucinations, to arrive at the precise correct answer. The results were absolutely stunning. The model produced a flawless and very long chain of reasoning. The final answer was perfect and completely precise. It actually performed the complex exact unit conversions entirely on its own. It demonstrated clean division and even found the correct remnant. There were absolutely no illusions or errors, just strict, undeniable logic. It was a complete triumph for our small model, proving its immense value for specialized mathematical tasks. Section 5. Trials and broken code, the hero stumbles. Every fairy tale has its dark forests, and our hero faced some severe trials in deep science and language.
First was a deep scientific test about ancient finds in Morocco. We asked it to calculate dates based on DNA mutations. But here, a cunning forest Leshy seriously confused our neural network. While it calculated the numbers perfectly, its final historical interpretation was entirely erroneous. It completely confused the age of the bones with the date of migration. This just reminds us that math skills do not always equal real-world understanding, and small models still lack deep scientific context. Next, we moved on to the ordeal of coding. We asked it to create an HTML file with an animation of fish and bubbles. We used the graphical interface of the LobChat program. Unfortunately, this interface turned out to be absolutely terrible and very inconvenient. The generated code contained strange and broken symbols. It was as if an evil swamp Kikimora completely destroyed our front-end development. The model was completely unable to find and fix the errors, resulting in a devastating practical failure. Finally, we tested its language skills. We asked it to translate a poetic phrase about a flowing river. The result was completely unreadable digital gibberish, kind of like ancient elders in a thick fog trying to read faded runes on old pieces of bark. This model was created solely for dry logic and code, and it really lacks general knowledge of the world. For tasks like this, large universal models would have done a much better job. This clearly shows us that when building your own agent, you must always choose the right tool for the specific quest.
Section 6. The Sovereign AI Future. Independence on Local Servers. Our journey nears its end. We have proven today that small models possess colossal power for narrow tasks. While universal models handle general requests better, these agile systems brilliantly solve narrow mathematical problems locally. This means you no longer need to hand over your private data to massive corporations. Sovereign algorithms are developing at an absolute incredible speed. Powerful artificial intelligence is becoming available in every home, running securely on our very own local IT infrastructure. A bright, independent future has already arrived, and it is running securely on our local servers. So what discoveries await us in the new digital Cyber-Rus? As carved wooden domes harmoniously intertwine with neon highways in the bright rays of the sun, we see a world of endless possibility. Thank you so much for your support. It really helps the project grow. Keep questioning, keep building, and stay curious.